Welcome back to the Flipped Classroom. Our topic today is called complex fractions. So, what is a complex fraction? Well, it's really just a fraction within a fraction. So perhaps that sounds a little intimidating, but follow the steps and it'll surely be okay. So our goals are to turn every term into a fraction. This will in fact make it easier. Find a common denominator, multiply every term by the common denominator, and then factor and simplify. So here's our first example, 2 over 3x divided by 1 over x. So hopefully you can see what I mean by a fraction within a fraction. Here's our main fraction, and we have a fraction in the numerator, a fraction in the denominator, and the whole question's a fraction. So hence the term complex fraction. Our goal is to focus on just the denominators. So I'm going to look at this denominator and ask myself, what do they have in common? Well, since they're monomials, I'm just looking for the number and variable. I see a 3 and an x. So I would say my common denominator is 3x. Now that I have that common denominator, I'm simply going to multiply the top fraction and the bottom fraction by 3x. Notice when I write it, I'm putting it in the numerator of the top fraction and in the numerator of the bottom fraction. Now, the whole point of doing that is in the hopes that I kill the fraction. So you'll notice this 3x and this 3x on this fraction will cancel. So in this whole top part, I'm left with just the number 2. And you'll notice this x and this x will cancel. So I'm left with the 1 times 3, which gets me a 3. So my final answer is 2/3. Phew. Now, if you're still feeling a little fuzzy on that, we're going to do quite a few examples today. So stay with me on each one. This is a pretty big topic for us. So let's give another one a whirl. Number 2. X minus 1 over x all over x plus 1. So if you flip back to your notes, the thing I said first, our goals there, is we want to turn every term into a fraction, and this will make it easier. So you can see that this is already a fraction, and I can easily make this a fraction by putting it over 1. And I can make this a fraction by putting it over 1, and this term a fraction by putting it over 1. And now I'm just going to focus on my 4 denominators. Well, 1, 1, and 1, clearly the number's 1, and the variable x. So I would say my common denominator is 1x. Now, of course, you don't need to say the 1, you can just say x, but I just want to stress 1x as my denominator. So I'm going to multiply all 4 terms by 1x. All right, so you can see I've got my x's next to every term, and of course I'm putting them on the top. Now the goal is to kill any fraction if I can. So if I look carefully at this fraction, I have an x on top and a 1 on the bottom. Nothing will cancel, so I'm just going to multiply them together to get x squared. On the second fraction, though, here's where that killing the fraction comes in. This x on top and this x on the bottom are gone, and I'm left with a minus sign and a 1. On the bottom here, nothing can cancel, so I've got x squared. And again, nothing will cancel here, so I've got a plus x. Now, before I try to simplify, remember you have to factor before simplifying. Okay, so I can't just cancel this x squared and that x squared. Doesn't work that way. I have to factor. So on top, hopefully you see some dots, difference of 2 squares. So I'm going to say that's x plus 1 and x minus 1. On the bottom, not dots this time, x and x tell me GCF. So I can pull an x out, and I'm left with x plus 1. Now something should cancel, and you'll see the x plus 1 on top and the x plus 1 on the bottom cancel. So on top, I've got x minus 1 all over x. And here is my simplified fraction. All right, let's try another one. I've got x plus 2 over 1 plus 5x plus 6x squared. So you can see this complex fraction. I've got this main fraction, and then I have these fractions sitting inside of it. So again, that's why it's called a complex fraction. So I want to rewrite every term so that it looks like a fraction. And that's very simple. Anything that's not a fraction, I'm just going to put over 1. So x over 1 plus 2 over 1. Got my 1 over 1. And then these guys already are fractions, so I've got my 5 over x plus 6 over x squared. So I'm only focusing on the denominators of each term to find that common denominator. Don't really care about the numerators right now. So if I look at the numbers, I've got 1, 1, and 1, so my common number's 1. And I have an x and an x squared. Now remember, you have to pick the one they both go into. Well, x can go into x, but x squared cannot. So I've got to use x squared as my common denominator. So I'm going to multiply all 5 terms by x squared. So you'll see I have all my x squareds next to all 5 terms. And my goal, again, is to kill the fraction if I can. So in this fraction, nothing cancels. X squared on top and a 1 on the bottom. So if I just multiply, that's x cubed. Second fraction, nothing cancels. So that's 2x squared. On the bottom, nothing cancels. So I've got my x squared. And now here's where we have to pay close attention. This x squared can cancel with this bottom x, and I'm left with just an x. So I'm going to say plus 5x. And now these x squareds completely cancel, so I'm left with just plus 6. Now, remember, I'm not done unless I've factored. So I can't just start canceling x squareds. That's not allowed. I've got to factor first. So on top, I can plot an x squared, and I've got my x plus 2. And on the bottom, remember this is your add, multiply. I'm going to say x plus 3 and x plus 2. Multiplies to 6, adds to 5. And lastly, I can cancel anything that's the same on the top and bottom. So x plus 2 and x plus 2. So I've got x squared over x plus 3. Now I can't cancel that any further because this is being added. And remember, we're only